Today's lesson is the second day of section 9.3. We use much of what we learned yesterday concerning trigonometry to do some solving of right triangles. I think you'll find this material much easier than what we did yesterday with the identities. Alright, we'll just some of this material you've done before. You did it in geometry, and so this is just a refresher on how you use your trigonometric ratios to solve a triangle. You're going to have to be able to use both the trig ratios and their inverse functions, and we'll review that material in order to find missing angles and missing side lengths. So we'll look at a couple of examples here. Use these examples to illustrate our point. You're given in this problem one angle measure, and you're given one length. Hey, remember that capital letters are used for angles, and then lowercase letters are for the sides opposite those angles. When the question says to solve the triangle, all that really means is just find all your missing pieces. If you look at this problem, recognize that in this problem, easiest thing to find is going to be angle x. We know that those two angles in a right triangle are complements, so 90 minus that is 65 degrees. To find your lengths, you need to look at your information you have. Since you were given the 25 degrees and you were given the 8, you could do two things right now. One thing you could do is use tangent, because tangent is opposite over adjacent. Ask yourself, hey, what will my calculator do? Will my calculator do tangent of 25, or will my calculator do 8 divided by x? Of course, your calculator will do tangent divided by 25, or tangent of 25. So 8 divided by that tangent of 25. Again, make sure you know what mode you're in on your calculator. Make sure you're in degree mode, and when you work that out, you get 17.1. And you probably should label that units or something. Look at the context of the problem to know for sure. Hey, last piece, finding y. You have two ways to do this problem. You could do another trig ratio again. Maybe you'll do sine or something like that. But you could always do Pythagorean theorem as well. You'll notice that I'm going to try to use information that I know for sure is correct. Alright, I know the tangent, I know the 25-degree angle is correct. I know the 8 is correct because those were given to me. If I was to screw up little x, for example, I'm going to get little y wrong also if I use it to try to solve that answer. Hope that's a little bit of a refresher on how to do that. Here's an example now where you're given two lengths but none of the angles in the problem. If you want to push pause for a second and try to do that, you can. So for me, easiest thing to do here is to figure out my third side. Plug in my leg, plug in my hypotenuse, go through, solve that. You're going to get A as approximately 7.1. Now to do an angle here in this problem, I would recommend using 7 and 10, simply because those again are whole numbers, they're exact numbers, they're numbers you know are true. 7 is opposite angle B, 10 is the hypotenuse, so we use sine for that. Your calculator will not do the sine of B, doesn't know what B is, so we're going to use the inverse sine of that. Inverse sine cancels out sine, just like square rooting cancels out squares. Multiplying cancels out dividing, all of that. If I take the inverse sine of one side, I must take the inverse sine of the other side. So on your calculator, take the inverse sine, not the reciprocal, not the x to the negative 1 power, but the inverse sine. That's right above the sine button. And what that really means, what you're doing is you're saying, hey, what angle has 0.7 for a sine value? Which angle has that as a sine ratio? And remember, in right triangles, that's always a consistent thing. So every right triangle that has 0.7 for a sine value, alright, has a 44.4 degree angle for it. Now we have that angle. Again, finding angle A is pretty easy using complementary angles. Subtract that out, and you get about 45.6 degrees for angle A. Yeah, I went through these pretty quick. You make sure that you take some time with the practice problems in class, making sure you know how to do these given various problems. Okay, last problem we're going to look at right now is an application problem. We did some of these back in geometry, quite a few actually. We referred to them as angle of elevation or angle of depression problems. I really like these problems. They're hands-on. How do I use this in real life kind of problems? They're easy to work with, and it's great application of this right triangle trig. So we'll set the problem up here. First, before you do it though, let's just look at the idea, the general idea of what angle of elevation and angle of depression are. Suppose you got a sun in the sky, and you got a flagpole, and you got the sun's rays that are shining down, creating a shadow, and the shadow is going to fall to the ground. And as it does that, you'll see that it creates a triangle using the edge of the shadow, the ground, and the vertical flagpole. The angle that is being formed with the ground is always referred to as the angle of elevation. If you were to look up at the sun, that would be the angle of elevation. The angle that is its alternate interior angle, right? The angle that is formed with a horizontal line and that hypotenuse, is the angle of depression. Big thing you need to remember, especially if this does not ring a bell at all from back in geometry class. The angle of elevation and the angle of depression are always equal. So if you're asked for one or you're asked for the other, you can always solve the angle of elevation. So let's work on an example problem here. When you're doing these problems, really the biggest part of the problem, most important part of the problem is understanding what the question is telling you, drawing a picture of that, and then fitting it to a right triangle, creating a right triangle from the given information. So in this problem it says that you have a person that is standing 115 feet from the base of the Washington Monument. He measures the angle of elevation to the top of the monument, and that angle of elevation is 78.3 degrees. Question is simply, how tall is the monument? So remember, step one, draw a picture. Don't worry about a triangle at first, just draw a picture. So what's in the problem? Person. It doesn't tell you how tall he is. So we have to assume that that person is laying on the ground. Don't assume any certain height for him. You have the Washington Monument. We know that the Washington Monument is 150, or actually we know that we're 115 feet from the Washington Monument. So understand that will be a horizontal distance from the monument. And we're looking for the height of the monument. And that will be the vertical distance of the monument. Now create a right triangle with this information now. His line of sight to the top of the monument, that horizontal distance, the vertical height. Put your information in, use SOHCAHTOA now, and solve the problem. What are we solving for? We're solving for that height. Which trig ratio relates this? Well, if I have that angle, I have the opposite side, I have the adjacent side. If you remember SOHCAHTOA, that's going to be tangent. A lot of tangent ratios when you're doing angle of elevation problems. So setting that up, tangent of 78.3 equals opposite over adjacent. I can do tangent of 78.3 with my calculator, multiply that by 115, and you're looking at an answer of 555.3 feet. Is that answer reasonable? Always check for that as you're done. As you label that answer, check and see if it's a reasonable answer. Is it reasonable that the Washington Monument's 500 feet tall? Yeah, sure. Alright, what wouldn't be reasonable? 5,000 feet tall? 50 feet tall? things like that. Now, last thing I want you to think about, what might I do to make a problem like this more difficult for calculus? You had problems just like this in geometry. Now that you are 2 years wiser, what would I do to make this problem more challenging for you? Be thinking about that, as there's a good chance you'll see a question a little more challenging on tomorrow's quiz. So if you want to get a little jump on the homework assignment for tomorrow, you want some extra time to be able to work on extra practice problems and things like that, because some of the problems do take a little bit. We're going to work on page 588. And let's see here, let's pick out some good ones here that I think will be helpful to you. Let's do problems 63 through 76. Alright, good luck with those. We'll see you tomorrow.